Hello everyone, thank you for watching my video today on integrating functions, whether using long division or completing the square, or also we're going to look at something else called adding or subtracting a constant to an integrand as well. But first, let's start with long division. So first of all, when would I use long division? Whenever we are being asked to integrate a rational expression whose numerator's degree is either the same or higher than the denominator's degree, we should be using long division. Okay? So first of all, let's remember how to do long division from your pre-calculus days. If I'm going to divide I like to always use a filler here for anything missing. So 0x squared is going to go in there. And then we divide first term by first term. And what's left over here would be 3x. And then I multiply. Subtract down. We should get negative 10x plus 5. And we can no longer divide again. So my answer for division would be 3x plus 5 minus 10x over x squared plus 4. Okay, so now, the reason why we do that here is now we can integrate separately. Okay? So now I can integrate, I can make this here to an integral of 3x dx plus the integral of, and I could do all this in one, or I could split it up into multiple integrals. So I'm going to do 5 over x squared plus 4 dx minus 10x over x squared plus 4 dx. All right, so this first integral should be second nature to us by now. It's just going to be 3x squared over 2, so 3 halves x squared. This one, we would recognize, if we brought that 5 out in front, we should recognize that as an tangent inverse. So it's going to be plus 5 times 1 over root 4, which is 2, tangent inverse of 1 over 2 times x, or just x over 2. And the last one there, if we do some substitution off to the side, so then 5 du would equal 10x dx. So I can write this as minus 5 integral 1 over u du. So it's just minus 5 ln absolute value x squared minus 4, x squared plus 4, sorry, plus c. And that's our final answer. So we have another one here, which if you want to try to pause the video at this point and try on your own, you're welcome to do. If you do so, come back and check your answer. I'll walk through it. If you don't feel ready that you want to try one like that yet, you can just go ahead and continue on with this video and pause as needed. So here's all the work I did for the second one here. So over here, first is the long division. Maybe I should separate that. That's the long division here. And I got this as my answer for that. So I set up my integral, the 3 integrals. The first one pretty easy to do, and the other 2 requiring some work. So the second one I did some substitution for. And the last one, again, we'd recognize as a tangent inverse integral. So again, you can pause this video as you need to check it out any further, but here's the final answer you should have got. All right, second technique for today is completing the square. So you should know how to complete the square, again, from your Algebra 2 or pre-calculus course. Completing the square helps when quadratic functions are involved in the integrand. For example, the quadratic can be written as a difference of 2 squares by adding and subtracting the b over 2 squared term. All right, so a lot of the times this is when we have a quadratic in the denominator, like we see in this problem right here. So I'm going to start this problem by doing exactly what we Actually, I'm going to write that dx off to the side over there. Doing exactly what we said over there and setting up a completing the square. So I'm going to rewrite this as 1 over x squared minus 4x plus 7 dx. All right, then we're going to complete the square. So negative 4 over 2 squared is negative 2 squared, which is 4. So I'm going to add 4 here and add 4 here. Now this becomes 1 over x minus 2 squared. Oops, sorry, I meant to subtract 4 here. Plus 3 dx. And again, now we could recognize this as another inverse tangent integral where u is x minus 2, our a is root 3. So our answer here would be 1 over root 3 tangent inverse x minus 2 over root 3 plus c. All right, the next slide, I do have another one very similar to this. It's a little bit more complicated, though, for 2 reasons. 1, it has a negative leading coefficient, and 2, it's a sine inverse. So if you want to pause the video at this point and try the next example on your own, you're welcome to do so. If not, you can follow along as I walk through it. So don't look at all the work for this yet. Let's just focus on one step at a time. So I first just rewrote it in descending order like this. Again, you can pause this video at any point if you need to. Then I factored out a negative. Then I set up and completing the square. One thing to notice here is that when you add 9/4 here, you're actually subtracting 9/4 here. So I have to add it here. And then I complete the square like so. And then when we get to that part, I just rewrote it again. It's all about recognition. Again, we recognize this is a sine inverse integral, with that being u, this is a, and du would be dx. So we can jump right to our answer here, and then simplified version there. Okay, so again, if you need any more time here, you can pause the video at this point to go back and look through it again. All right, and the last technique we're going to learn today is by adding a constant and subtracting it, obviously, as well. So with this first one, we're going to do 0, but let's talk about this before we do one. The final integration technique of the day may sound quite strange. How does adding a number, in this case 0, to the numerator help us find an antiderivative? While it may be viewed as a trick, this method provides an easy way to transform an integrand into something more manageable, and therefore integrable. Fortunately, it's not likely that you will see this type of integral on the AP exam. So, for example 4 here, I'm going to start by writing it same denominator. In the numerator, I'm going to do 1 plus e to the x minus e to the x. Why would I do that? Well, watch what happens now if I separate this into 2 separate integrals. Well, this is just 1. So now I'm integrating, oh, I forgot dx there. Integrating 1 dx. And the second one here, I can use a little substitution. To transform this into 1 over u du. So that would just be x minus ln absolute value of u, or ln absolute value of e to the x plus 1 plus c. And I guess we could actually drop the absolute value bars there because this will always be a positive number. So we can just make that parentheses if you want. So again, I have one more here. The last one's a little bit more complicated. If you want to try it on your own, you're welcome to do so. If you'd rather just follow along on the video, you can do that as well. But let's take a look at this last problem. Adding and subtracting a constant, so basically, again, adding 0. All right? So in this case, I'm going to add and subtract 1. So I subtracted 1 and then added 1. And then why did I do that? So I can combine these two. That's why they're highlighted there. To go 2x minus 2 and split it up plus 1. So I take that 2x minus 2 and make that one integral, and then the plus 1 is the other integral. All right, and the second integral, I complete the square. So you can see I did complete the square here. The first integral, I can use substitution. Substitute for the whole denominator, and the numerator becomes what I have left. So a little bit of integration, and then a little bit of completing the square here will leave me with a natural log and a tangent inverse plus c. All right, that'll do it for topic 610. As always, thank you for checking out the video today. Hope to see you again soon.